Good morning. How are you today? You can just give us a muffled yeah. My name is Stalnaker. I'm with Hub Culture and the ICE Hub, and I'm very pleased to welcome you here today. To those of you on the live stream all around the world, good morning from Glasgow. Good evening, good afternoon, wherever you are. I'm so pleased to bring Vinay Gupta and Mattereum to the ICE Hub to talk about circularity and blockchain, and to talk about some of the technical innovations that are driving change in the world of climate change. Wouldn't it be great if climate change had another meaning? If we were talking about climate change in the sense of we're changing our planet for the better, for a better climate. We all know the numbers, we know the outlook, and it's my personal belief that we need rapid change at system level to have any chance of adapting to the realities of ecological climate change. So I'm really pleased to bring this panel together and introduce everybody. So we have Greg Smithies from Fifth Wall, which is a large investment and venture firm focused on climate. We have Matt Kistler, who's the president of McDonough Innovation and MBDC, which is working on really leading at the kind of alpha point, the pinpoint of the circular economy, the thinking through William McDonough, who is our partner here at the ICE Hub. And this location is a collaboration between McDonough Innovation, Hub Culture, and Ourania's company, and Beauty Kitchen. Ourania is the product manager for which is actually reinventing packaging. We'll talk a little bit about that and how they're creating circular economy packaging for fast-moving consumer goods. And then as well, Vinay Gupta, who I've known for many years, kind of an inventor, a sage, a little bit of a Jedi, and one of the founders of Ethereum, was one of the 7 people who first developed the technology for that, and then left to look at stuff and how we think about stuff in the context of digitization, particularly smart contracts. And that led to something beyond Ethereum called Mattereum. So we're gonna have that discussion today. I think I'm gonna hand over now to Vinay for a brief minute, and then we sort of get into a conversation that I'll help to moderate around circularity. And I'll tell you a little bit about Van Oxygen, which is one of our contributions to the circular economy that's launching officially on the 10th. So welcome, Vinay.
Hi, everybody. Welcome to the event. The circular economy kind of trip for me starts maybe 20 years ago when I was working at Rocky Mountain Institute. And that was where I first got exposed to the concepts of circular economy from MBDC. There was a close partnership between Rocky Mountain Institute and MBDC in those days. And that stuff really stuck with me. So as I got further into the blockchain, there was always this thing of like, eventually we're going to get to the point where we can use the blockchain for things which are genuinely important. The technology will mature to the point where it's useful. And we're at that point today. But I want to hand over to Matt to really, frame the circular economy, tell the story of how it's changed over the last 20 years, what MBDC up to these days, and really give the journey up to this point where we're all springing off from. So thank you. Over to you.
Will you stand or sit?
I would stand.
Okay. 20 minutes. Great. Well, first of all, good morning, everyone, here in Glasgow. It's great to be here. Matt Kistler with MBDC and McDonough Innovation. I look at circularity from a consumer standpoint. My background is in manufacturing. I work for really large brand companies. I also spent a lot of time in retail, where I tried to do sustainability at the world's largest retailer. And it was an ongoing, and still is an ongoing effort. And then I also worked in tech, and more recently have joined working with McDonough Innovation and MBDC. But I look at things through the customer lens, but also through how products are made, but more importantly, how they're designed. And the new qualities of thinking in a circular way are as you start at the very beginning of the product to build it the right way. And that's the fundamental idea. And so part of cradle-to-cradle assessment looks at all the key components of the products. We start with the raw materials. We look at the potential to be circular of those products after use. We look at the water, we look at the air, the energy, and the social fairness in the creation and building of the product. So it's really a very holistic, circular approach. And that's the encouraging thing I see with what Mattereum is doing and how we're joining the circular economy. Because having been a manufacturer, having been a retailer, it's difficult for any one company to do everything without working with other parties or other groups or collaborating with others. So if you're a raw material manufacturer, you need packagers. You need people who are making packaging that's circular. You need to be sure that you have a distribution system that's also thinking the same way. And at end of use, what happens to that product then? So there's some missing pieces to that circular economy. And I'm encouraged by what I'm seeing, what Mattereum is doing, because it does fill a void in that missing circle. So my thoughts are pretty simple. I like how the consumer will use this product. Consumers want confidence. Consumers want products they can trust. They want brands they can believe in, and they want a price they can actually afford. But when the product is met its original intended use, where does it go? And that has always been a missing link, because the linear economy that most of us probably started with, or certainly my age group started with, of the kind of linear model, never had to take that into consideration. But if you have that built into a circular economy, and there's a way to actually measure, to understand what the product is made of, where it's sitting, where it's going, what use it can go to next, and really important, the confidence of that product, that's going to be able to be used after use in a right way, that's actually what it says it is, that the ingredients are safe. That's critically important, because it's okay to be circular. That's nice. But if it's not safe to begin with, you're just redistributing a problem to the next generation or the next group of people or the next product. So by looking at the complete material health of a product and all the other components of circularity and having that information about a product is really critical to make a circular economy work. But more importantly, as I started, having that confidence with the consumer. Because without that customer confidence, it's not going to work. As a large retailer, I worked for a company that it was everything about the confidence of the customer. Once you lost that customer trust, you lost the trust in the product. So to maintain that, you have to know what's in it. And that's what I'm encouraged by the conversation that we're having here, is how do you maintain that information? How do you know what's in the product? How do you feel safe and secure about it? And that will allow you then to have a true circular economy work going forward. So that's my opening, Vinay.
Thank you. Could you talk a little about the history of circular economy? We've had this concept for 20 years, and I think it'd be interesting to talk about, kind of what happened in the first 10, what happened in the last 10, what you want to happen in the next 10. Because you guys are at the center of it, right? This is your show.
Well, that's so I must say, my first exposure to circular economy was just thinking differently about how products were created. And then the major piece of that were not only what was coming into the product, but what the use of the raw materials or the sources of the materials could be used afterwards as resources. Bill McDonough has I think a magnificent way of speaking about the circular economy. And one of the terms that Stan and I have both been but corrected is that it's more about sources first, resources when you use it again. Am I getting that right, Stan? Okay. So that's the way to think about it. I think that's what's changed from maybe 10 years ago, was that we weren't thinking about the circularity of the raw material, because we weren't always thinking about if it was safe or not to begin with. I think one thing that I've certainly learned, that if it's not safe going in, you're just creating a really a mess, literally, for someone else to inherit and take care of. So by having that safety and security and knowledge of what's in the actual raw materials, that allows you to begin that way. So that's why I think having the information about the product is so critical. That's the big, I think, shift that's happened within the last 10 years. And then where I'd like to see it go would be in a place where we would actually know what the raw materials were, what was in the product, what was available, what was it used in before. But if you're buying things like beams in the ceiling, are they still good to use? What's the warranty on the beam in the ceiling? What's its life now? Or what's its reuse ability after? That's really important. And I think if we have that system put together, where once again, the consumer, the user, the customer of the products feels safe and secure and with knowledge of the information about the product, that allows trading then to occur with other companies versus just always using a raw material where we're kind of recreating and using an asset or that source. We're actually able to start using resources as the raw material. And that's what's going to be, I think, really encouraging for the future. And that's where I think it's got to go. But today, in most supply streams or most raw materials or in commodities, that's not doable. And in some industries, it's starting, but other industries, it hasn't even begun. So I think once that begins, that will become really encouraging. There will be pain points, there will be errors made, but we have to fix them. And I think the one thing that's really great about the circular economy is it does require us all to collaborate differently, but also work together and understand how the entire system has to work. My term was always putting the system in the room. You need to put the whole system in the room to really understand what needs to happen. And I think this is the start of something great that could happen. Encouraging.
Thank you.
Anything else?
Anything else that's on your mind? You have the time if you want it.
No, I'm pleased to be here. This is encouraging. The conversations this week, I think, are what has to happen. But I think the one thing is we just can't talk about. We actually have to do some things. And so what I'm encouraged about is people like you working together and let's make a difference happen versus just talk about it and 10 years ago meet again. Great, thank you.
Alrighty. It sounded like we were getting a little feedback from this guy. Should I adjust it a little higher? Is that better? Okay. Could you toss that in my chair? All right. Thank you. That was a great place to start. Just check. Are we good? Yeah, we're good. Okay. So what I'm going to talk about today is, well, we're going to cover a lot of terrain. The basic framework that I'm going to lay out is a data strategy for the circular economy. And it's a data strategy that enables a financial strategy. So what we're hoping to build here is a kind of infrastructure and financial services harness which will support tens of thousands of circular economy businesses. It's a kind of base layer that would be akin to something like Visa or Swift or maybe something like even Wikipedia for products. But also connected to the financial instruments, so it would have similarities to the kind of global network you have for things like credit card processing. The time scales are both immediate in that we're starting today, but also long in that we envisage this growing over decades until it becomes the default way of owning goods. So with that scope in mind, I will begin. I'm Vinay Gupta, CEO of Mattereum, and here we go. So what we're going to be talking about here is 4 steps. Point 3, why blockchain? One of the things I'm going to be talking about in a little more detail is that we have just helped one of our partners, Avalanche, become a net zero chain. And we believe it's the first actual net zero blockchain. They're offsetting all of their emissions for operating the chain. So we're finally out of the situation of having to offset every single blockchain transaction we do often for tens of dollars of offsets per transaction because the blockchains are so dirty, we finally have a plausibly clean chain. So just bear that in mind as we're talking about blockchain. Do put down the pitchforks. We have a solution for the carbon problem. And that literally came in yesterday. I think the public announcement will be today. You're literally the first people to know. So my background, I spent my 90s wandering around America, riding freight trains and writing flight simulators for the Air Force. I also had some involvement in medical imaging. I was a graphics engineer, came up with a few world's firsts. After 9/11, I got religion in a serious way, like, oh, I need to go do something about the state of the world. Went to Colorado, wound up at Rocky Mountain Institute, and spent about 5 years associated with the Institute, editing books, writing software, writing papers. Helped the Biomimicry Guild get the Acid Data database together, worked on Smallest Profitable and Winning the Oil End Game, which were two very important energy policy books. And that was where I got exposed to circular economy and lean and a whole bunch of other thinking about the sort of methodologies. Then I wound up at the Pentagon in a variety of military and civilian think tanks, largely working on resilience, worst case scenario planner, nukes, pandemics, state failure, complex systems. I used to carry a business card that said, I don't get out of bed for less than 1% mortality. It's true, that was a phase, that was a thing that I did. Around that time, I also invented a refugee shelter called the Hexier, which was intended as an open source shelter that could be constructed hundreds of millions of units so that we could have some way of catching the anticipated climate refugees. And I expected that project to take 30 years to reach scale based on the study that I'd done of other things that had that kind of historical profile. So we're now 20 years into that project. There's one commercial version which is being used in refugee camps. There are tens of thousands of people that know how to build them, and they're popping up in the States in homeless encampments. There are about a dozen commercial companies doing small run manufacture. Hexier, it's another thing. And Mattereum, I was the project manager for the launch. So I think I was about employee 30. I came in a little after the gang of 7 got together, gang of 8. But I was very, very involved in setting the paradigms for that project. So that's a bit about the roots, and I hope that explains part of how we're working. So, I've just covered this, the deep influences. I want to point to Shaping Things by our colleague Bruce Sterling. Bruce is a science fiction writer, and he's a remarkable thinker. He wrote this book, Shaping Things, about 15 years ago, and it's a total inspiration for everything that we do. It covers a model of how we break down the physical and digital interface so that when products are in the field, data about product use is continually folded back and iterated into the next edition of the product. So it's a way of thinking about upgrading reality. If your couch happens to have a cushion which always slides off, that information goes back into the system, and the next edition of that couch will not have a cushion that slips. It's like QA for the entire world, and many other things. Okay, so concepts of circular economy. Circularity can happen either in loops that are very close to the consumer or loops that are very far from the consumer. So if you imagine something like a plastic, you could have a thermoplastic which can be melted back and cast into new products. You could do this with glass. But to get there, you have to collect it as post-consumer waste, ship it back to wherever it's going to be reprocessed, turn it back into whatever you're going to turn it back into, and then you have to reship it. You pay the cost of manufacturing, you pay the cost of shipping. That's both energy and money. And then it comes back to the consumer. So that approach is the sort of longest arc of circularity. If you come in much closer, you can imagine a situation where the circular economy is you have a thing that you're using, you're done with it, you sell it to your next door neighbor, and now they're using it instead of you. We still have a circle. The thing is still going from user to user. It's going around a loop. But the loop is now literally you walk 12 feet across a corridor and give somebody a laptop. And what we are focused on is very much this idea of the short loop circular economy. This is a thing where we keep the goods in their manufactured forms and they go round and round and round and round. And you think, doesn't that sound like eBay or thrift stores? The answer is yes. The idea is to upgrade the infrastructure for second-hand markets to the point where the second-hand markets become a highly effective redistribution system for physical goods, so that when anything does become no longer useful to the person that currently owns it, we immediately catch it and give it to somebody else that does want it. and they pay you for that privilege. That loop, just getting that right, how much stuff that has potential future users is currently winding up in permanent storage or landfill? And the answer is it's a lot. Let's see, let me just skip. Here we are, right? We have enough slide about that. So the numbers are just staggering, right? I mean, the numbers are so large that it's very difficult to think about the numbers. But I mean, if you work in tech, do you have that kind of couple of boxes of old laptops somewhere in your house? That thing with all the electronic waste that you've generated over the past 15 years that you haven't figured out how to get rid of? For software engineers, this is ubiquitous. Like, we tell stories about our boxes of old gear, and all of that stuff is potentially usable to somebody, but there's no good way of getting rid of it. It's a ubiquitous problem. You know how big these waste flows are in your own life, the clothes you no longer wear that pile up, and it exists not just as garbage, it exists as the stuff which is in your house that you're not using that is just costing you time and money to maintain. Right? It's the dead closet problem. Oh, I never wear this, I should get rid of it. Well, I'll do that later, and it goes back in. Because the energy required to get rid of it and recover the value in it is just so large that it's easier to leave it in permanent storage. And this is hundreds of millions of tons, tens of trillions of dollars of materials. It's crazy. So the crux of this is, imagine a world in which every single thing that you buy with the intention that you're going to sell again. This is the critical transition point. This is where the action is. So if I buy something with no clear disposal plan, it goes one of two places. It goes in the garbage, or it sits in my house as clutter, right? The point where you buy something and think, one day I'm going to sell this on eBay, rare. The point where you buy something and think, one day I'm going to, throw this into a charity shop, rare. Those are kind of gutterball positions. We don't plan for an asset to go into eBay or into a thrift store. We plan nothing at all. We just buy the thing and we figure out how to get rid of it later. So imagine a world where when you buy something, you have an explicit plan for getting rid of it baked right into the purchasing of the object, right? This is the critical plan. That is, that's really how it works. So there are markets which kind of work this way already, and these are the global commodity markets. Global commodity markets, if you happen to have 100 tons of nice looking steel beams, sitting in a scrapyard somewhere, there is a way of getting rid of that. If you have hundreds of millions of tons of aluminium coming out of a set of mines, there is no problem turning that stuff into commodities and getting it moved around in markets. All of that infrastructure works fantastically well, and as a result, there is no shortage of materials which are in these kind of loops, right? This is a thing that we know how to do. It's happening already at vast scale. And the trick of this is that the commodities, one slide too early. The trick of this is that the commodities markets rest on massive, clear knowledge about the commodities which are being bought and sold. There's no ambiguity about what you're buying and selling in a commodities market. It is nailed down what it is that's being purchased by huge documentation which goes along with those commodities. That's why they're able to achieve such tight performance in those markets. And the problem that we have for things which are not tightly specified is that they hemorrhage value. We talk about this in terms of the doubt discount. When you're buying something secondhand, when you're buying something after it's gone through one or more loops, your question is, how do I know that this is the good one? How do I know that this is legit? Is this the real goods or is this not the real goods? And that doubt discount reduces what you're willing to pay for the object, right? Some of that reduction is rational, like there's an actual risk, you're not really sure what you're buying. Some of that reduction is irrational, you're just not sure, you can't be bothered, it's this kind of psychological friction. Some of it is also active fraud. There are people out there who are selling fake secondhand things, and you don't want to buy a secondhand thing because you don't want to be the victim of fraud. So closing up that doubt discount is a question of getting trustworthy information about physical objects, and that is the essence of what we're selling, right? We've got a mechanism for getting trustworthy information about physical objects, not by solving the problem ourselves, but by establishing a market structure which creates a market for that information. We call this a product information market. So, you have some widget, some set of people that know about these things are correctly financially incentivized to tell you the truth about this, and that exists as a service to match buyers and sellers. So think of a multi-party deal. One buyer, one seller, 2, 3, 4 independent experts. The independent experts are correctly tied together into a financial structure, which allows us to actually purchase the object using their expertise instead of our own. Because those experts know more about the asset than either the buyer or the seller. Okay, I think we covered that. There we are. And the size of this, I mean, it's right there, right? Trillions of dollars of uncertainty about what things are worth and what their provenance is. A good example is wine. Wine is about 400 billion of transactions a year, and the estimate is that fraud is minimally 10% of that market globally, and at the high end, it's as much as 30%. And that's not untypical for those kind of collectible or fine art objects. So, another thing that goes along with the ability to get really good information is a thing that we call parametric search. So parametric search is, if I buy a pair of shoes, will they fit? Right? The size of my foot is a parameter, and I'm just measuring, the shoe which is in the store against my foot. Right now, for the most part, you do that by going into the store and trying on shoes. If you buy them online, what do you reckon? 20% error rate for shoe sizing online? 30%? If you buy shoes online, how much worry do you have when you buy shoes online that they will arrive and they won't fit? Right? Now, that's not because we don't know how big the shoe is. It came off a CAD/CAM system just like everything else. And it's not like we don't know how big your foot is. You can have a tape measure, or you can take pictures of it with a fancy phone, and it will immediately give you a very clear size of your foot. So why can't we match the online shoe to the foot with 0% failure? Because every time we send out goods, if they're not the right size, they go back, cost, inconvenience, footprint, and it turns out that brands like Amazon, or infrastructure like Amazon, a lot of what comes back into Amazon, they don't bother reselling, they just throw in a landfill. And that's a real problem. That is not how the world should operate. There should be no situation where something winds up in a landfill just because we didn't know what it was. You see what I mean about how that sort of sounds absurd in the age of the internet? The idea that we're landfilling things just because we can't identify them? Like, what is all this artificial intelligence for? Anyway, that, right? So the way that we solve that problem is this structure that we call a trust community. Now, trust community is a social way of thinking about something, which is actually a whole mess of very complex legal contracts, arbitration clauses, international arbitration options. There's a lot of infrastructure that goes into building something that looks this way. So the notion of a trust community is another way of thinking about this thing we call a product information market. I have an object, right? I don't know what this is. I got some idea, it's a recording doohickey. If I'm selling this thing secondhand because we got a different one, what do I do with this? Well, I try and describe what it is, but I'm not an expert in recording devices. You want to buy it, but you just want to solve your problem. You're not an expert in recording devices. Where do we inject the knowledge into the deal that allows us to do the transaction safely? And the answer is, somebody who knows about audio gear takes a look at it. Oh, this is one of these. It's in the following condition. It has all of its features. I've clicked all of its buttons, everything works. I did a test recording, it's fine. And what that person issues is a warranty. They say, just like any other consumer warranty, if you give me an additional $6 on the transaction, I will make a guarantee that this thing is in good working order, and I've also got a precise specification for what this thing is. It's a really simple, really crisp transaction. But that's not the only kind of information that we want about this thing, right? What other kinds of information do I want? Well, I know what the object is, I've got a specification for it. What if I also want to know, is this genuinely the thing that some pop star used to record their first album? Now I have a provenance question. So say that I want to know whether it's compatible with another device. Oh, can I plug this into my soundboard? Does that work? Oh, actually let me check. And some other person knows about the soundboard, can check compatibility. So for even very ordinary objects, what you need is 3, 4, 5 different kinds of knowledge which come together to give you the information you need to make a purchasing decision. And that purchasing decision is how the thing goes one more time around the circular loop. Here is a steel beam that we're taking at the back of a building that we're disassembling. Okay, great, we got the steel beam. Is that safe to use in the building that I'm about to construct? I need to figure that out. Well, now what do I need? A mechanical engineer, structural engineer? I need somebody to maybe take some samples from the steel and verify that it is the steel we think it is. There are a whole bunch of different things that we need to do before we can nail down for sure what it is that we're dealing with. And that model, right, this is what we call the trust community. That's the structure of the product information market. And almost anything in the world which is bought and sold already has deep wells of expertise that could be structured into these trust communities. If you're buying and selling guitars or shoes or cars or gold or anything, somebody understands those markets inside out. And if you can correctly financially incentivize them to give that knowledge to you in a form you can act on, we can start reattaching objects to their stories, so we no longer have objects losing their value just because we no longer understand what they're worth. It's a way of making sure that the objects don't wind up in landfill just because we forgot what they were. And this is the crux, right? Every object in the world, we have a clear understanding of what it is. It's searchable, it's accessible, it's reachable, we know how to talk to it, we know how to talk about it. And as a result, we can maximize the value of the post-consumer and indeed industrial stream of assets. All the stuff that you bought, that you used, that you no longer think is quite as good as you wanted it to be, you want something else, you're bored, you lost interest in skateboarding after you twisted your ankle, all of that stuff immediately is routed to the person that values it most, because we no longer have this problem that the second-hand goods lose their stories, become obscure, and then lose their value. And getting the transparency about what things are and having that be multi-person verification from different people with different knowledge bases, that's what we do. That's how we're going to build a circular economy infrastructure for everything. One of my colleagues, David Levender, discusses this as the reversal of entropy, which, that's a heck of a claim. Every time he says that, I'm like, really? Actually, in a sense, yes. Right? We take a situation which is chaotic and disordered, which is the waste stream. We add structure to it using the product information market as a way of pulling out value where none previously was accessible. Indeed, we are reversing entropy in a limited and not quite thermodynamic way. Does it fix the world? I think I've made a pretty good case about why this is actually an extremely helpful thing to do. I'm just going to pass right over that. So, key features of how we do this. This is not a theoretical system. We launched the first version of the platform this year, and we launched it for the goods which are already extremely circular. So things which are already extremely circular, fine art, right? If you think of a Monet painting, very successfully circular. One of our partners works in Stradivarius violins for the most part. They're a violin house. And it's a 200-and-something-year-old company that handles 350-year-old instruments, and they've been lovingly passed from hand to hand to hand to hand for 3.5 centuries. It gets no more circular than this. We also work in gold bars, so we have a gold bar set up with carbon offsets tied directly to the gold bar and multi-point authentication about vaulting. The stuff actually works. So that's where we started, and hence a bunch of blockchain infrastructure to move value around the system. That's Ricardian contracts. Force of law, this is the arbitration machinery, so that if somebody gives you product information and the product information is inaccurate, if they don't pay their bills because they made a mistake and you claim on the warranty, we have enforcement mechanisms that will work in 160 countries. We have custodians, which give us the ability to store the goods securely, which is again very important. The warranty structure, the thing that ties together all of the opinions about the object are these warranties. And the asset passport is the actual structure online, and I'll show you some pictures of those later on. And I mentioned arbitration. So that is a very simple model of the system. It's a lot of separate moving parts, right? We have many, many, many different actors because we have buyers, sellers, people providing product information, multiples, insurance companies standing behind them, court structures. These are quite large things. And this is why we think of this as being an infrastructure platform, because nobody is going to assemble that entire machinery themselves every time they want to sell a second-hand car. It has to exist externally as a deeply dug-in part of your society, so that anytime you want to resell something, you just put it into the pipe and off it goes. Okay, now, the fun part, right? Blockchain. the terrible, terrible thing that has the carbon footprint of Las Vegas for a bunch of people to sling around imaginary money, right? I mean, I've worked on it extensively, I know a lot about it, but it's impossible to shake the catastrophic environmental footprint that systems like Bitcoin have. So the Avalanche system is one of the new third generation chains. They've been live about a year, maybe a little longer, year and a half, based on a third generation consensus model. So there are kind of three models of consensus. There's what's called classical consensus, which is all the distributed systems kind of in the old days. Then we have Nakamoto consensus, which is what you think of as Bitcoin and Ethereum and these kind of proof of work systems. The Avalanche system uses a technique called simulated annealing, which was invented 40, 50 years ago as a technique in artificial intelligence and simulation. And it uses simulated annealing to reach incredibly fast, cheap blockchain consensus with excellent analyzability. The thing with algorithms is if the algorithm is sufficiently complicated, it's very hard to predict future performance. You just can't really tell what will happen. The Avalanche algorithm is very simple. It's so simple that I did consider explaining it today. And if anybody wants an explanation, come up to talk to me afterwards. I will wave my hands for 3 minutes and you will understand how it works. Part of what comes with that simplicity is utter mathematical predictability. So they can say extremely precisely under what conditions it will succeed, what conditions it will fail, and that means they can run it extremely lean. The total power consumption for the entire network is something like 100 kilowatts, which is the same as half a dozen houses running their normal electricity loads. It's a very, very light system. And as of yesterday, they bought offsets for what little carbon footprint they have. The estimate they've got is a little bit below 70 tons. The worst case scenario they had was about 430 tons, and they bought about 500 and something tons worth of carbon. So in all probability, they're nearly 10 times over offset. Even worst case scenario, they've got a 10 or 20% margin of error. So at that point, the entire transaction environment that we're going to be running this stuff on soon is reasonably light on its feet in terms of absolute consumption, but is also offset to net zero. And that's a big deal. That's the first time anybody's done that for blockchain. Why we're using it. So publication of what something is. The records about what this object are should be fully public, because otherwise the buyers and the sellers don't know if somebody is lying to them. If I've got private information about this object that I'm not disclosing, I've no way of knowing when I buy it whether I've got full information. So objects which are being sold, the information should as far as possible be fully public. There are some exceptions, particularly in the art world, but for the most part, the thing should be public. Change of ownership, again, for a large class of assets like houses and cars, it's important we have public records of who owns what. It is worth considering the extension of that paradigm to other classes of high-value goods, particularly things which change ownership really quickly. If you think of something like a professional TV camera, it might change hands 50 or 100 times in a year if it's being rented. So in those kind of situations, being able to publicly see who's currently using that camera and who currently owns it might be important when couriers are shipping it around and something goes wrong. You need to know who's currently attached to the camera. Guaranteed payments, extremely useful. So lots of these payments which we are doing between the people who are buying the object and the people that are providing warranties, those payments are often very small, 10, 20 cents, $1. To be able to do huge numbers of very small payments, you don't want credit card style charges. And also, as the person buying the goods, you want there to be no possibility that the payment for your warranty fails, because if it fails, you have no insurance. So in that situation, the public blockchain record of the payment is also the thing that gives you the proof of insurance, so you can immediately know what the legal status is of the object that you're handling. Finally, dispute resolution. We refer to this as litigation-ready records management. So all of the information about the objects from all the parties is structured in a way that if there is a legal dispute, you don't have to go through a complex discovery phase. You pull the information off the chain and you hand it to the arbitrator. Here are all of the pertinent facts, plus perhaps a couple of statements from the buyers and sellers in dispute. Very, very clean. So how do you actually get involved in this? Right now, the system is live and it's running for what we term appreciating assets. Gold, collectibles, fine art, shortly, whiskey, wine, and a couple other things. There's a river of stuff coming out of Hollywood, which we're very excited about. The appreciating asset practice is the thing that allowed us to get the software set up, and it's the thing that will allow us to generate more and more complex technology that a lot of people are using, because those are markets where people are really immediately ready to pay for provenance. And all of those markets are already extremely circular. We just don't think of it as the circular economy, because who thinks of an oil painting as a circular economy thing? But it is, so is a gold bar. This is a $500,000-year-old hand axe that we sold because we thought it was cool. Here, I should say, this is on the OpenSea website. This is on Ethereum, so this is the pre-avalanche version of the system. On Ethereum, we have to offset the transaction costs every time one of these things is created, because they're burning so much carbon to run that system. We just have to offset every transaction. OpenSea is the big thing, which is buying and selling NFTs right now. We are generating NFTs as the way of actually representing the assets and the ownership of the assets, because there's an enormous fully developed infrastructure that millions of people are using, and we're just another set of traffic in that existing blockchain infrastructure. So OpenSea is doing about $125 million worth of NFT transactions a day. It's essentially eBay for NFTs. And our stuff just slots seamlessly into it. Now this is the Mattereum asset passport. So this is the set of legal documentation, the trust community, the product information packets, the warranties. All of that is tied up inside of our asset passport construct. And you can see there are a large set of warranties. This is a gold bar, which is being sold as an art object. So there is both intellectual property in the forms of some pictures, plus the actual physical gold. You can see there's a carbon offsetting claim, and that is live right now. We have people buying and selling and trading gold bars bound to digital art as collectibles. We offset the carbon for the bars and for the transaction. So the mining of the gold itself is offset, the physical mining. And there are, I think, 4 sets of parties who have legal responsibility for those transactions. So when you buy one of these bars, you're getting multi-party warranties. Each warranty covers a different part of what makes the bar valuable. And it's live now. I mean, that's like a real working system. So the take, make, waste cycle infrastructure, right? Amazon is kind of the peak of take, make, waste infrastructure. It's a river of goods, and unfortunately, the vast majority of the goods that go down that river are going into landfill. This is going to become increasingly problematic as the circular economy becomes more and more and more a sought-after new default, right? That just can't be how reality runs. So what we're building is literally a circular economy structure which has the ability to grow not as a single monolithic mega corporation which owns everything and recycles it, but as a set of protocols which exist between hundreds of millions of buyers and sellers, and protocols, data standardization, dispute resolution, basically as services which support an entire economy. That is the aspiration, and the blockchain uniquely allows us to build these kind of systems, because in the blockchain environment, you don't have a single entity that owns the records for a physical thing, right? The blockchain is kind of a public utility. Anybody can write, anybody can read. You set some protocols up to make sure that you don't wind up with a bunch of destructive spam on your records keeping platforms, but the actual data storage layer is independent of the people buying, selling, and providing the information, which means that if all of the people who are interested in an object lose interest in it, the data is still there on the chain, and the new owners of the object still have access to old records, and they can continue to update and modify and write to those records. It's a very, very tight fit for what we need in a circular economy, because in a circular economy, if the thing's had 50 previous owners, the original manufacturer is not going to be taking responsibility for those objects. I will say, actually, this is a point I missed earlier on. In the example of trust communities for things like electronics, we would expect the original manufacturers to be a critical member of the trust community, because for them to recertify the goods as in good condition is easier than for anybody else. So if I'm the manufacturer of this object, one of the ways that I make money from the circular economy is that I take these objects in, I recertify them, and then the buyers and sellers pay me a warranty fee every time the object changes hands. And for a large class of objects, the manufacturers may actually be making more money recertifying objects on behalf of other people that are selling them second-hand than they get when they manufacture a new version of the object. So it's not that the intention here is to cut the manufacturers out of the loop and then break their business models. Rather, the manufacturers make pretty much the same amount of stuff they're making now. The second-hand markets give them 10 times as many customers as they had because all the goods they produced in previous years are still in circulation, and the manufacturers take a nick of all those transactions because they go in and they recertify the goods. So this is not something where we're talking about applying pressure to manufacturers to make them make less stuff. We have a world with near infinite human need. Every kid in Mexico that wishes they had a laptop, well, if it's a 15-year-old ThinkPad running Linux, they're still in good shape. So that possibility is that what we can use is this circular model to spread the existing manufacturing literally to the ends of the earth, so that all of the goods which are on their 4th, 5th, 12th, 15th owner continue to have utility until they're literally no longer fit for purpose. And very few things in this world are so broken that nobody would gladly have them. So this is basically the plan, right? We want to help all kinds of companies make huge leaps towards being net zero. They don't have to radically overhaul what they're doing. They don't have to radically overhaul their production processes. We might need them to put unique serial numbers on a whole bunch of stuff that's currently kind of anonymous, but we can start spreading the cost, environmental and financial, of manufacturing and using these goods over much, much wider ranges of people, amortizing the damage that the goods did in production immediately. It's not a hard thing to go into the Mattereum system, as long as we can individually identify exactly which products are which by something like a serial number. We can plug them right into the system and we can begin to get these companies made circular immediately. Let's see, I'm just going to skip over here. Last thing, you have copies of my book. I wrote this in the early stages of the pandemic. Originally, it was a tortoise project, and then it came out as part of something from Untitled. So it's part of a set of 6 books that are about the future. There was the future of politics, and there was the future of art, and a few other things. This is called The Future of Stuff, and it's specifically a book about new human rights. It's a book about the human right to know what is in the products that you're buying. If you're wearing it, if you're putting it on your body, if you're eating it, you have the right to know, and that right corresponds with the duty of the manufacturer to tell you. Right? Rights and duties come as pairs. This is one of Gandhi's key principles. So it's a book about the human right to know what is in the things that you're buying, and that applies to their carbon footprint, it applies to the working and labor practices of the people that manufactured them. And yeah, it's worth reading because it's part of the deep intellectual superstructure of Mattereum. Also take a look at Shaping Things by Bruce Sterling. And that is it. Thank you very much.
Thank you, Vinay. We're going to go next to Ourania, and then we'll go to Greg. Because you guys are re-innovating on stuff.
Hi, right, so first of all, my name is Ourania Dimou, and I'm very happy to be here today. Sorry, I had to say my name in my native language. First things first, so a big thank you to Mattereum and Vinay for inviting us here, and Nice Hub, of course. Just a bit of a background for me. My background is in sustainability and engineering, waste management and resource efficiency. So back at university when I studied sustainability and cradle to cradle, I never imagined that I would be in the same panel with the president of MBDC and McDonough Innovation. So thank you very much for this opportunity. So today I'm representing Beauty Kitchen and our reusable packaging program. So a quick background on Beauty Kitchen and who we are. Beauty Kitchen was founded by Joe and Stuart Sidley. with the mission to provide effective, natural, and sustainable beauty and personal care products. Effective because if a beauty product is not effective, then what's the point of using that? Natural because we believe in the power of natural ingredients, and sustainable because what is the point of creating something that is anything other than sustainable? We are a B Corp, so we have incorporated B Corp principles, social fairness, environmental considerations in everything we do. Most of our products are cradle-to-cradle certified, so we have incorporated cradle-to-cradle principles on our products. But throughout its journey, Beauty Kitchen realized the issue of packaging in the beauty industry. As a consumer, you want to buy your cream, your shampoo, your shower gel, you want to use that, but you don't want to use the packaging after you're done with your shampoo. So beauty industry is facing a big single-use packaging, and as a response to that, Beauty Kitchen has created Return, Refill, Repeat, the program to address the single-use packaging for Beauty Kitchen. Since then, we have come a long way. We have recently launched our program that is now available to brands, consumers, and retailers with the aim to democratize the safe and circular economy. So what is RE? RE is a program for reusable packaging. You buy your product in reusable packaging, you use it, you can return it, and then we take care of the packaging. We wash it and we treat it in a way that is safe to reuse on different kinds of products. So we offer this through two different models. You can see your refill stations here. So you can buy a bottle, you fill it with your product, you use it, you return it, and you can refill it. Or we provide products in reusable packaging, and you can buy it the same way that you would buy any product. You use it, you return it, and then we take care of the rest of what needs to be done to the bottle so that it can be reused on other products. Now, a very interesting part of what we do that is very similar to what Vinay was presenting just before is how do we ensure that packaging is treated the way it has to be treated so that it can be reused again and again and again. So in our packaging, we have applied QR code technology. So every piece of packaging that we offer has a unique QR code. This way we can track packaging from the moment it is manufactured throughout the supply chain. We know exactly what kind of product goes in it, how far it has traveled, and by knowing its history, we can determine its future. We can determine what needs to be done to the packaging to be effectively reused. We can maximize savings, and we share that with consumers through an app. So when you use your reusable packaging through RE, you can track your carbon savings, you can track your plastic savings, you can see the history of your packaging. So hopefully we take consumers in the journey with us. So I'm more than happy to talk you through the refill stations and the return stations that we have here in Ice Hub. And yeah, this is Beauty Kitchen and RE, and thank you very much for the opportunity to present.
Oh, thank you. It's lovely to see something which is like immediately here and now practical. Like, you know, there it is. You're looking at the circular economy.
Yes, exactly. So we are available to work with brands and retailers and consumers. We are all about collaboration and working together to democratize the safe and circular economy. So, yeah.
Thank you, Ourania. That's Ourania Dimou. And you can find these products in 400 locations over the next year across the UK, right? So it's rolling out across the entire country.
Yes, that's correct. We will be launching in 400 different locations with hundreds of products. Yeah.
That's fantastic. That's amazing.
Yeah. Okay.
Yes, an exciting year ahead.
We're going to now talk about the money. Greg.
Yeah. Thank you very much for taking the time here and for the fantastic speakers that we've had before this. Let's adjust this camera because I think I'm a little taller than our last speaker.
Quite a bit taller.
Yeah, so whilst we're getting this set up, just maybe 30 seconds on my background so you can get a feel for how I see the world. I currently head climate investing at a fund called Fifth Wall, which I'll tell you about in a second. Prior to this, I founded and ran climate investing for BMW. That was how do you decarbonize, obviously, transportation, but all of the things that go into the vehicles, right? So steel, supply chain, manufacturing type stuff. Before that was Elon Musk World. For a number of years, I reported directly to Elon. I was head of finance and operations at 2 of his companies at the same time. At the Boring Company digs tunnels and sells flamethrowers. And Neuralink puts microchips into people's heads. You would be shocked how many people might think Elon has already put a microchip in their head. And then prior to that, I started my investing career at a fund called Battery Ventures. The Battery Ventures is about a $9 billion fund, and probably what's most important here about how I originally got into climate investing is I didn't spend my time there looking at the next TikTok. I don't understand humans, so I would never even be able to figure out what the next TikTok would be. But I did spend all of that time looking at industrial tech, so big, boring industries, energy, manufacturing, construction. And these are the big industries that unfortunately have been heavily underinvested when it comes to venture capital dollars and people putting money into the R&D and technology that we need to decarbonize them. And that goes all the way back to my first job, which was at an ammonium nitrate explosives plant. So I found myself at Fifth Wall, and Fifth Wall is the world's largest venture capital firm that focuses on what we call the built environment. But think of this as construction, real estate, infrastructure. And this sounds like it's very niche, but it turns out that there is no way that you can decarbonize the world without going through buildings. Buildings account for about 40% of all of the greenhouse gas emissions out there. They consume about 40% of the power. They consume about 40% of the raw materials out there. By the way, if you ever don't know a stat about buildings, it's 40%. And about 40% of all of the materials in landfills is building rubble, right? It also happens to be the largest asset class in the world, $326 trillion of buildings out there. And in most countries, it's somewhere between 15 to 20% of the GDP of those countries. So if you really want to think about one industry that kind of touches everything in our lives, we live in buildings, right? We work in buildings. The things that we're manufacturing are going into buildings. We're consuming all of these goods inside buildings. This is the one industry that if we can make a dent in this, it really pulls along most of the rest of the world and all of the big manufacturing supply chains and everything that the other folks here have been talking about. The only other thing I will mention about Fifth Wall is that Fifth Wall's model is actually an industry consortium. So we brought together about 70 of the world's largest owners, operators, and developers of real estate. They're across about 15 countries. And the reason why this is important is for so many of the problems that we're tackling out there, like the circular economy, this is a collective action problem. Many of the industries around the world aren't like tech, where you have 1, 2, or 3 companies that control most of it. Most of the industries out there are very diversified, very fragmented, and so you need to be able to bring together the entire industry. Real estate is just like this. It's very fragmented. Typically, the biggest real estate companies in any country only have 1 or 2% market share, right? So we think it's very important to bring together the entire industry, and we're seeing this sort of model come together in other industries. But I suppose what I'm really here to talk about is a little bit of inspiration, which is, so far today we've heard from a couple of startups and people really on the forefront of solving these problems. And the money side of it, which is the venture capital dollars that are flowing into the space, I think is something that we should all be very heartened about. Because I personally think it's a travesty that over the last 20-ish years, we've essentially lost a generation of the best and brightest minds all going and working for Google and Facebook, right? And they've gone and spent all of their IQ points optimizing ad click-throughs, right? This is a travesty for humanity. But what we've seen here at COP26 and over roughly the last 2 years is we've seen hundreds of billions of dollars flowing into venture capital and growth equity and all of these other industries to back climate change companies. And just to put some numbers around this, because I think there are people who ethically want to start companies to help solve the climate problem, but at the end of the day, those people almost by definition will always just be the front sort of 5%. How do we get the other 95% of the best and brightest minds out there who might be starting a company to think about that company being in a circular economy space, a climate positive space, those sorts of things. And at the end of the day, with my capitalist hat on, money is a very good motivator here, and the fact that we've got all of this money flowing into the space, I think is very heartening. To put some numbers around this, and I apologize because all the numbers I have in my head are about the real estate industry because that's where I spend most of my time. As I said, the real estate industry is a $326 trillion asset class, and trillion with a T is kind of like monopoly money when it gets to that scale. But when you look at how much just this industry is going to have to spend to decarbonize itself, the numbers are roughly $18 to $36 trillion over the next 20 years. So in rough numbers, think of that as $1 to $2 trillion every year for the next 20 years. To put that in perspective, where all of those best and brightest people have spent their time making all of this money at the Googles and Facebooks of the world is essentially in the internet, right? How big is the internet? How big of an opportunity is the internet? The entire internet is only around about a $1.2 trillion market. So what we're seeing here is that the opportunity for entrepreneurs to go out, start companies just inside climate tech, just inside real estate, is 1 to 2 internets per year for the next 20 years, right? So what I'd really like to do here is inspire more entrepreneurs like the ones that we've heard from today to go out and start companies in this space. Tell your friends, because I think here we're preaching to the choir. These are the people who ethically want to do these things. But for the other 95% of the best and brightest minds out there, the people that we would love to get on board here to start their companies, the size of this opportunity is monstrous. It is probably the largest venture capital startup opportunity that the world has ever seen. And so hopefully we can band together, pour some money into the space, all get fantastically rich and save the planet at the same time.
I like that plan.
I'm going to take another minute to tell you about the final theme on this panel, and then we're going to go into a group conversation with all of you. So again, I mentioned I'm involved with Bill and with Beauty Kitchen to present the ICE Hub. One of our key messages for this week is around the idea of net positive, that we need to go beyond net zero, and we need to get to a net positive world. Bill talks about not doing less bad, just do good. And a lot of the conversation in the climate space has been around sort of drawdown, around reduction, around sacrifice. It's kind of like downer ideas. But there's another pathway forward, and I encourage you guys all to just take a second and sort of bring your mind to 2030, the point where the Sustainable Development Goals have been achieved, and start thinking backwards from a point of success from there back to here, and kind of draw that intention and draw that reality back. We're going to be doing a whole day on this on the 11th, where we're going to spend the day in 2030 bringing back the solutions in a kind of mental way. But this is important because net positive is a different attitude than drawdown or sequestration, which are components of getting to net positive. But I want to encourage you guys to think about net positive in that way. And I personally believe, I've known Vinay for 20 years, and he's always been one of the people that I go to for some of my ideas, and other people that know me often say like, wow, where do you get your ideas? And Vinay is one of those people. On the concept of net positive, this was a conversation that I had with William McDonough as we were kind of intellectualizing the message of the ICE Hub. And for us, it's extremely important to think about what I call a digital value layer on top of everything. And that's sort of the key point of what Mattereum is about, and one of the reasons that Mattereum became a partner here. When you think about crypto and blockchain, there are 3 layers. There's layer 1, which is the protocol layer. That's Chia, which you'll hear about tomorrow. There's layer 2, which is about appending information on top of a blockchain, whether it's Avalanche or Chia or even eventually Bitcoin, Lightning, or Ethereum, which are far less efficient than some of the new things coming out. But that layer 2 data is in the middle. And then on layer 3, you have new ideas that can arise because of layer 1 and layer 2. And so one of the layer 3 ideas is the thing I'm going to tell you about quickly, which is our contribution to this panel, and it's called Venn Oxygen, and it's launching on the 10th. So the idea of Venn Oxygen was really based on Bill's idea of net positive. And so what I started thinking about is like, what does net positive mean for nature? And we have been very early in the digital currency space. We launched Venn, the world's first digital currency, in 2007, 2 years before Bitcoin, before blockchains. But it's not a blockchain currency. And in a way, it was too conservative because it's asset-backed. One of the assets backing Venn is carbon. So it made us the first and only environmental currency. They just talked about offsetting and going carbon neutral with Avalanche. Venn has been carbon positive for 15 years because carbon is embedded into the DNA of what we do. But it wasn't enough. And it wasn't enough for a lot of reasons. One of the reasons is it's not a blockchain asset, and so it misses some of the inherent technological advancements of that. But we built bridges to blockchains. But this spring, I started looking a lot at oxygen. And I invite you to come on the 10th and learn more about it. But the reality, the headline, is that we're losing 1% of the world's oxygen a year. We thought we had 1,000 years of oxygen, but it turns out we might have 600 years of oxygen. And if we screw up oxygen, everything goes extinct. The reason that we're screwing up oxygen is because of carbon, because we're putting too much carbon in the air. That carbon is being sequestered mostly by, any guess? Oceans. Guess where 80% of the oxygen that gets made is made? Oceans. The other 20% is being made on land from trees and forests, and we're destroying that. And then in cities and urban areas, because of heat and pollution, we're turning O2 into O3. So we're on our way to a much bigger problem than climate change, which is oxygen change, oxygen depletion. So I went really geeked out on this all of like the first half of this year. And then in May, had a kind of dream epiphany that became Venn Oxygen. So what Venn Oxygen does is we're training our artificial intelligence to pay trees, essentially, for producing oxygen. So this is a net positive side. So instead of like offsets and drawing down carbon, which is needed, we can also go net positive by looking at the positive production value of nature. So for every molecule of carbon sequestered by a tree or plant in this room, there's also a molecule of oxygen emitted. And so what we're doing is we're calculating the tons of oxygen that are emitted by nature, and we're creating a new coin. It's like Dogecoin for climate, right? It has zero value on day one, and the way that you earn it, the only way you can get this coin is by staking land or forests, and eventually ocean, in a way, onto a shared map, the collaborative map. And that collaborative map is filled with underlying information about the oxygen production value of those natural areas. We're working with One Earth in the 50 bioregions. We're working with other universities to get the data to calculate how much oxygen is being produced by certain areas. And that land, once publicly staked and publicly pledged to be protected with a layer of validators in the middle, will then begin to earn VO2. And the value of VO2 at the beginning is zero, but as we've seen in the crypto markets, something that begins at zero, like Bitcoin, can go to $60,000. If it's Dogecoin, of which there are trillions, it can go to 30 cents. There's a natural cap to the supply of oxygen, which is based on the total amount of trees and nature that are being preserved. So we're creating a payment system for indigenous communities, for governments with public lands, and for you in your own backyard to be able to earn value for the work that nature is doing to produce oxygen. So a thing like Mattereum is interesting for us because it can be a layer for authentication and validation in this existing open source, I might add, system. There will then be bridges to various chains that are green, like Chia, potentially Bitcoin Lightning, that will allow then Oxygen to offset the entire world of blockchain. Because suddenly you can actually buy an oxygen credit in the form of a VO2 and offset the energy consumption of a chain. So we can, through VO2, pay you for protecting trees and then turn the blockchain, any blockchain, carbon neutral. So that's why we're here. But I'm going to now turn this over to our conversation. And why don't we start with any questions from the live stream for those of you out in the vast energy consuming internet and here in our beautiful room at the ICE Hub. Any questions? Please. And if you could just say your name and who you're with.
My name is Julia Hales. I wrote the original Green Consumer Guide with John Elkington way back in 1988.
Thank you, Vinay. I should have done that.
I'll start again. My name's Julia Hales. I wrote the original Green Consumer Guide with John Elkington in 1988, and many other things besides that. Very much working at the moment in the circular economy and energy issues. But I wanted to ask Vinay about the quality of products, because obviously the whole sort of principle of looking at the circular economy relies on products that actually do have a second-hand value. And so many products today are actually made with zero durability. If you take a printer, it's completely and utterly designed not to last because they make more money by selling more printers. And the whole concept of what they're doing is extremely poor. I mean, you talked about Amazon chucking away their products. I did some work with B&Q. I was absolutely shocked to discover that they actually build in at least 10% of their products being returned, sometimes with no faults at all, and they just bin them because they have no possibility of repairing them, no possibility of selling them in there, and it's absolutely shocking. We also have that in fashion, obviously people burning the clothes because they don't want people to have a second-hand value. So there's lots of things within that, which means that, that we cannot simply build it into a circular economy world because they can't be reused or disassembled or whatever. So I'd just like to have a think about that. And I have one further small point, which is it's interesting at the beginning of our sort of green consumer campaign, eco-labeling, life cycle assessment, all those type of things, that commodities were actually the biggest problem, because people would say to us, how can we possibly have traceability, because it goes back into the commodity supply chain and we have no information that we can give you because it's all very generic. But from what you were saying, in some ways that has turned completely upside down by actually coming about that commodities are much easier to track than many other things. So I was rather interested in that point.
So the crux of this is we have to think very carefully about how we got into the mess we're in right now. And the answer is that in the old days, you know, the sort of paradigm of retail was you walked into the shop, you bought it, and you left, and that was all there was, right? Then we got into this thing where we had things like catalog shopping, and you know that began to change things. Then we moved on to the internet, so you could see what the object was on the internet, and you could buy it. And so we've seen gradual intrusion of IT further and further and further in. And over the last sort of 50 years, we've had 3 dramatic insertions of what you would think of as being information technology and statistical reasoning into commerce. So the first one is the quality control revolution, which happens when statistical process control really blossoms in Japan under the care of a guy called Deming. Then you've got the quantitative finance revolution in the 1980s, and then you have targeted advertising. So what we've done is we've basically applied massive big data, statistical reasoning, modeling approaches in investment, in manufacturing, and in sales. The next step is we start applying those things to product use, which you can see a little bit with your phones and your watches and all these devices that have enough brains on board to know how they're being used. The next step is then product reuse, resale, disposal. What's happening is we're just pushing the IT infrastructure a step at a time towards the garbage dump, and eventually you get to the point where the goods have been tagged. Like if one of your bottles winds up in the garbage, there's a decent chance that at some point there will be a machine that will just take pictures of everything as it goes by on a conveyor belt, pick out the thing that actually has an owner, and then ship it back to them. Hey, one of your reusable bottles was in the garbage. We've got like 500 of them. We'll ship you, like once every 6 weeks, we'll send a truck. So it's a temporary condition that we have this waste stream, right? And I think that if we are careful about this, what you will see is a flight to quality, right? The fact that we're in a general economic decline in the West, America and Europe are getting poorer rather than richer. There's a lot of wealth concentration. People are rapidly becoming too poor to buy garbage, right? What they want is durable things that will last. You get bored with the durable things, you sell them, you take the money, you buy somebody else's durable things. As long as the goods are sufficiently durable and as long as there's good liquidity, you can change your look 12 times a year, and you're really only just, you have the same footprint as if you'd used it, you're wearing the same clothes, because it's just durable goods being rotated around those people. And that as a process, one of the reasons I got very excited about this whole thing was it was the first time in years that I'd seen an environmental innovation that could produce both higher quality of life and lower footprint simultaneously. If you had the access to all of the clothes in Glasgow that people didn't want to wear anymore, and you knew exactly what size they were, you get up in the morning, you decide you want a new outfit, you feel like wearing a ridiculous purple and green thing, and immediately, there you are dressed like a frog. Wow, okay, that was amazing. You do it for 3 days, you get bored, you sell the clothes on, somebody else tries the experiment. It's not that we're going to have less consumer choice in this paradigm. What happens is you get dramatically more consumer choice, and the consumers that are in the circular paradigm have more money because they're wearing better clothes and they're paying less for them. I think really the take, make, waste cycle, the kind of fast fashion stuff, I think it's going to get driven out by this combination of poverty and computers. Sorry, that was kind of a long answer. Did that cover the stuff you wanted to know? Okay, good. Thanks.
Thank you. Do we have another question?
So I thought I might go next just because I'm right here. So I'm actually Julia's son. My name is Monty. I'm currently doing a master's at Bristol University, but I'm also setting up a business called People Power, and we want to be the internet of impact finance. And one of the particular areas we're focusing at is this hugely exciting area of impact cryptocurrency, which I'm very excited to hear that there's 2 new projects for us to potentially integrate into our platform. And yeah, so I'd love to reach out to you guys afterwards. But my question was for Mattereum in particular, which was, do you have a plan for a token sale? And if so, what will this token, will it be a utility token, security token? What will its function be? And maybe some governance implications there as well.
Yes, so one of our kind of partner companies just is in the process of acquiring the Gibraltar stock market. Now, you may say, why would a crypto company acquire a stock market? And the answer is because you can then do securitization of assets. So you take a house, you take a car, you take a fleet of cars, you fractionalize ownership, and you can then float these kind of assets. It's probably going to be a year or so before they get through the regulatory to get that fully up and running, but maybe pilots in 6 months. So in terms of tokens, we are extremely conservative, right? I got legal advice in 2016, which is one of the reasons that I'm not worth $100 million, because at the Dow crisis, I was holding a lot of Ether. I got legal advice, and they were just like, if that turns out to be a security, you're currently promoting an unregistered security and profiting from insider trading. Like, you're in real trouble, kid. So I divested, and to this day, I remain a no-coiner. In all probability, there will be a Mattereum token. It will be a relatively simple thing which is used by people that are, for example, dealers, and it will offset their fees. Every time something goes around this system, Mattereum takes a small fee. Basically, we would be doing pre-sale of services.
I say that with some caution. This is still a process which is sitting legal. It's a relatively conservative plan. In fact, for the most part, we're VC funded and we intend to remain VC funded. But in the crypto markets as they currently stand, if you don't have a token, there is no way for your fans to monetize promoting the thing that you're providing. So for us, if we want to have 100,000 rabid fans who are pushing the circular economy every time they talk, every time they build something, every time they buy, we have to provide a way for those people to get involved, and at this point that means tokens. It'd be nice if we had real regulatory clarity about that, and I keep hoping that the UK government will take a lead on this, because with the city's infrastructure, you can imagine that they could be a globally dominant force in this next generation of finance, but that requires giving the City of London the ability to really seriously define black and white rules about how things work and then implement those rules. So, in short, yes, but with a lot more caveats that you'd expect from a crypto company.
Thank you. One of the things that we've been talking a lot about inside of hub culture is the creation of a DVL. We call it a digital value layer. And the premise is that everything eventually, every object, will have a digital value layer. And the crypto markets, which did go from, I was shocked to hear that 1.x trillion is the size of the internet, when the crypto markets this year passed $1 trillion themselves, and it briefly hit 2 trillion. To think that the crypto markets were worth as much as the entire internet times 2, that was a real revelation. But I'm curious because, Greg, you have so much experience working in this world, like your time at BMW, your time working with Boring Company and with these kind of material areas of the economy. Are you guys thinking about this digital value layer concept as you look at investments? Because you're looking at real estate, but are you seeing this value layer emerge across the physical economy?
Yeah, I'll say we do see it as an aspect here, but at the sort of end of the day, it's kind of like it's an unlock, but only an unlock for the underlying sort of science, right? So what we're typically investing in is things that are, for example, clean concrete, right? Like at the end of the day, if you do not have the clean concrete, you can't put a digital value layer on top of it and then trade the carbon credits or whatever it is that you're going to monetize with that value layer. So to us, it's cream on the top of some underlying core scientific breakthrough that actually allows the ultimate sort of carbon solution, right? So your clean steel technology or your clean concrete or your high efficiency HVAC system or whatever it happens to be. So we definitely do see these as ways to sort of juice returns, because typically what is, if you look at any technology, when the buyer of that technology, let's just use a real example here. We're investors in a company called Turntide Motors. Their motors are 30 to 60% more efficient in the real world. They go into the air conditioning systems inside buildings. Sounds super boring. It turns out that half of the world's electricity goes through motors like these. It's a $100 billion market just for the motors. They consume about $1 trillion of electricity every single year. So like super boring actually moves the needle if you've got a motor that's 50% more efficient on average. So there we would, the buyer looks at that and says, okay, I can get value out of this motor either from cost savings from the electricity, or maybe I'm going to go and prove with some digital value layer that I have cut my electricity usage, therefore my CO2 has come down, and therefore I'm going to get some value out of, say, a carbon offset market, right? And that way, because now you've got 2 layers of value for the buyer there, they're getting savings on their electricity and they're getting this other digital value, whatever it happens to be. Now you can take a technology that maybe was a 3-year cost payback and turn it into a 1-year cost payback, right? And then the great thing about capital expenses that are like a 1-year cost payback is you can sell those to a CFO at a company who is an active climate change denier, and he will still want to buy them, right? So long story short, it's cream on the top, but it's a very valuable cream to help these products get to market.
Let's go back here. Would you mind to pass the mic back? There we got Xenia.
Oh, thank you very much for this question so far. I have a question on around innovation and standards. You talked a lot about standards in the commodity market is one of the things that are facilitating the second-hand market especially, and also in a circular economy. Again, we can all see the more standards we have, the easier it will be to have a second-hand market and sort of reuse stuff. I guess also with and like bottles and to get full adoptions and so forth. But could you elaborate a little bit more on your thoughts around how that interacts with innovations? Because standard also prevents innovation. People deciding what the standard should be, shouldn't be, monopoly power, again, how that will sort of work in a capitalist world where, yeah.
Yeah, I mean, welcome to my next 15 years, right? I mean, that's what I'm expecting to spend a huge amount of my time doing in the next phase of this. So, right, so once upon a time, there was a thing called WSGI, Web Services Gateway Initiative. I think it was gateways. So WSGI was this model of building a kind of data layer that you could interrogate to find out what goods and services other people sold. So you'd go to, IBM.com/WSGI gateway, and then I could say, right, so give me an ontology of everything that you sell that I might be able to use. And you could search their offerings, and there'd be APIs for everything. And it was a sort of platonic ideal of machine-to-machine trade. And I think it was real popular for about 3 years, and then everybody decided it was impossible and gave up. The platonic approach, where we build standards in a top-down way, is also very enshrined in ideas like object-oriented programming. It's deep inside of SQL databases. There's a book called Seeing Like a State, which is, I want to say by Scott, maybe? Which really gives you a great summary, a great model of how that sort of top-down platonic ontological approach works. Standards that come from that approach tend not to work in the real world, because the real world just doesn't grow from a platonic tree. There is no sort of blueprint in the causal plane from which physical world is rendered. It just isn't that way. On the other side, you've got things like folksonomy. And folksonomy was a sort of approach that gave us things like hashtags, where you have a community of people that want to communicate something, and in a sort of semiotic way, they find a symbol like hash YOLO Friday, and they give hash YOLO Friday a meaning which is only inside of their little semantic bubble. And then when we try and get information between those semantic bubbles, we have to have translators. So the folksonomies work, but they don't work globally, and it creates a kind of meaning crisis. Mattereum sits ontologically in a different camp. Our approach is very much modeled around aspect-oriented programming, and I'm trying to remember the name of, there's a philosopher who's done a whole bunch of work on this, and the name is completely escaping me. I talked to him not 2 months ago. I'm trying to remember the name of the, anyway, I'll post something in show notes. So the aspect-oriented programming model basically suggests that for a single physical entity, you can have different sort of social groups with different folksonomies that will categorize the same object relative to their perception of it. So we take a single physical object, 4, 5, 10, 25 different groups are interested in that object. Each one of them brings their own ontology and maps it to it. And what we record in the blockchain is person A uses ontology B to describe thing C. And that relationship, because it accepts that the object has multiple ontological standings inside of different groups, gives us the ability to do innovation. So we have an object, it's in the standard ontology, it's got the following fields and definitions, it meets the standard. Somebody comes along and says, I have a new ontology, I'm going to place that object in the new ontology, and it becomes one in a chorus of voices, each of whom is looking at the object from their own perspective. And by putting the perceiver into the system as a first-class actor, it gets us into a position where we can accept that innovators use a different way of looking at the world than everybody else. And if they define ontologies which are value representing, then more people will use those ontologies, and we wind up with, here's the standard model, here's the new model, here's the really new model, here's the bleeding edge model, multiple different ontological representations attached to the same object. And when something is being bought and sold, if you require a financial compensation if the ontological representation is wrong, you know, if the descriptor is wrong, the standard is wrong, then those people are getting paid for making the data available in that format, in that ontology, and as a result, they could get income from creating ontologies to represent valuable attributes of objects. So in short, it's an evolutionary approach to ontology development.
But maybe I see it in the digital perspective and from data, but like just adapters for power in the UK versus others, you know, the iPhone and all of these type of things. So you also see it applicable there, that you will not sort of hinder too much of the innovation that we need to come up with the new solutions.
Absolutely. I mean, being able to correctly describe things is very, very, very helpful, right? Like, hey, I got these chargers in my travel bag. Do I need to buy anything before I go on this trip if I'm taking this new camera? Just to have a thing which will reliably answer those kind of questions really helps, because it tells you whether your equipment will work, and it tells you if you have to buy something or not. We don't expect there to be much influence from what we're doing on that kind of standardization, because my expectation is that the European Union is going to become the globally dominant actor in setting those kind of technical physical connector standards. I think EU is just going to throw its weight around and force that stuff.
Up here in the front. Up here. Yeah, I'll give you my. What's your name?
Hello, everyone. My name is Zoe. I work for a climate tech startup called Altruistic, and we look at essentially helping large companies with their carbon management and sustainability management. Thank you, everyone. That was a really interesting conversation. I loved hearing about all the technological innovations, the coins, and as well as I think some of the new startups that are coming about looking at refillable bottles. One of the things I wanted to ask about, and this is directed towards Matt, is obviously to be able to engage in this transition towards a circular economy, one of the largest things we need to do is help large corporations engage in that transition. For example, you mentioned that you worked with a large retailer. What have been some of the solutions that you found have worked with large retailers and with large corporations and getting them to transition? And how can that work in conjunction with some of these technological innovations that we're seeing?
So just be sure, I actually worked for a large retailer. I was the chief sustainability officer at Walmart.
Okay.
So it's a great question. So thank you. When I was at Walmart, the opportunity we had was to really convene different groups so that we could work on specific areas to move forward. And so I'll give one example. We did a lot of work on packaging. Not only to create better packaging, but also to figure out what to do with the packaging after it was used. And we actually turned packaging into a very large monetary income for Walmart in the selling of corrugated and other materials. But it took a lot of work from the suppliers, but before that, the raw material producers, as well as the packaging manufacturers. So when I mentioned earlier about putting the system in the room, it was if you were working with, let's say, a manufacturer, or you're working with a packaging manufacturer, or a retailer, I would understand where the biggest opportunity was for innovation, who needs to be involved in that conversation. But I think we are all driven by the financials of it. And if it's doesn't make financial sense and it doesn't work for the customer, usually its life is pretty short. And so that's the opportunity I would say you have, is how do you understand the basic problem, what's the solution, but who needs to be involved in the process? Because I think too often we do one-offs or two-offs, whereas you really need to get the system working together. Hope I answered your question.
Great, thank you.
Thank you.
Hi. Yes, I have a mic here. I'm Catherine Chen from X, the Moonshot Factory. Thank you so much for all your presentations. Super interesting. I have a question for you, Stan, actually. Because one thing that I was working on in my past life was talking about money and financial incentives as a powerful motivator. I mean, one of the big issues with the current status that we're in is that environmental issues are negative externalities and they're not incorporated into the financial system. So something like VEN 02 is super interesting. I guess one issue with offsets is, oftentimes there are issues with leakage, we're not able to capture the entire jurisdiction. I think really to really embed everything, we need a global currency. So question is, I guess, how is Venn 02 kind of thinking about that to be comprehensive and also be, start with forests, but maybe move on to other sectors, eventually maybe real estate as well, something which is deeply embedded in all the materials going in there.
Thank you. I love that question, and it demonstrates a pretty deep understanding of the sector. These are issues that we've wrestled with a lot. So I would say there are three main components to my coming answer. One is there's negative externalities, but there's also positive externalities. And so what's really interesting to this is that oxygen is a positive externality that we're not even thinking about. And so that's kind of interesting. It's also a positive externality that's global. And so the reason we make 1 VO2 equal to 1 ton of oxygen is that you can roughly calculate. Now, our algorithm and our AI, we would love to work with X, by the way, to improve the intelligence of the AI so that it could get more granulated. But the AI, and as you understand how AIs work, it's really a collection of data points and information and APIs that feed in to a growingly sophisticated algorithm. And so at the moment, we have about, let's say, 24 factors that feed the AI and the algorithm to calculate the amount of VO2 that a piece of land that is staked to the shared mapping, which is, by the way, a Google Map interface, calculates the amount of VO2. And so what's interesting about that is that it is fully global. So the oxygen tonnage of Amazon rainforest, we're actually giving it an upweighting for places like the Sacred Headwaters, or like British Columbian old growth rainforest at 1.1 to 1.2. Grasslands or wetlands, mangroves are weighted at like say 0.7 or 0.8. Even deserts, but which are wild deserts, are at like 0.3 or 0.4. I don't remember the exact numbers. But this is just an arbitrary thing that we created, but we wanted to upweight areas where old growth or real wilderness could be benefiting in excess. A monoculture forest that's like regrowth is, I think, weighted at like 0.5 or 0.6. It's still producing actually the same amount of oxygen, but the AI is choosing to upweight certain things from a more less objective point of view than just the O2. But the key value of O2 is weighted to oxygen tonnage, and that's fully global. The other thing that I think is super important for this, and we've learned this with Venn, Bitcoin won because it's open source, and it won because it's distributed. Venn, quite frankly, hasn't won because it's not open source and it's asset backed. And so we're not doing either of those things with this project. VO2 is fully open source. We're putting everything into a public GitHub repository, and we're inviting everybody to innovate on that, although we are setting some standards about that creation. The other thing is VO2 is not asset backed. The value is 0 as we begin to execute. But as we learned with Dogecoin, I bought Dogecoin in 2014. We just turned our Dogecoin into an environmental estate in Hawaii that we're doing a regenerative farm and a CEO meditation center. We put the down payment from our profits from Dogecoin. And so I'm kind of inspired by what Doge has done, even though it's been a joke meme coin that Elon has, thank you Elon for our estate in Hawaii. But the idea is that it started at 0 and it grew in value because the community believed in it. And I hope that will happen with VO2, open source, everybody can participate. It doesn't need to be a global currency because I think there are lots of global currencies that now exist and that can exist for different reasons. We don't have to be everything to everything. We just want to be everything for nature and trees. We want to honor and value the work that nature is doing as a positive externality. And then the final thing is compatibility. And so what didn't exist 10 years ago when we launched Venn was anything approaching a market. The only market for Venn was Hub Culture, our social network in our community. Today, it's a $2 trillion market. And the main thing for us is to work with people like Mattereum to build that validation layer for some intelligence. And then to work with people like Chia, I can't really say, but we will have an announcement with Chia coming on the 10th. You can maybe guess what that might be. But also things like Bitcoin Lightning. We think Venn on Lightning, which is, by the way, this thing that makes Bitcoin a little bit better, we could turn Bitcoin carbon neutral just by putting VO2 on Lightning and then letting miners buy VO2 at very low value and have the oxygen externality attached to the Bitcoin. If you attached VO2 as a wrapper, like VBTC, you could actually have green Bitcoin. And that would be coming from the oxygen side of the positive externality that we're evaluating. Does that help? Next door.
Next door. Hi, everyone. I'm Thomas Guest from New York, and starting a new organization structured as an innovation lab at the intersection of innovation and justice. So I think my question revolves around the concept of innovation. I think we're all here because we believe in it, but there's also an assumption that innovation drives everyone forward and that will trickle down into smaller indigenous local communities. I'm curious with system changes like this, which are very exciting, what a strategy looks like to actually get this in the hands of a local, maybe indigenous community that doesn't have access to the internet or has different access to some of the resources that we do in New York or in Glasgow. I think the second part of my question also angles towards the future of the physical components of blockchain. And we've talked about where this is going from the physical mining standpoint, tracking transparency around data for these offsets is a great start, but I'm also curious where you see this going from literally a physical resource vision as well into the future.
Sure. So let me take the second question first. The avalanche chain is very typical of the third generation chains. About 70 tons of carbon is their best estimate for how much they're actually burning per year, which is, about what you would expect from an American middle-class family. I don't want to say it's nothing, but it's negligible in the grand scheme of things compared to Bitcoin, which is cranking out something like 23 million tons of carbon a year. Offsetting Bitcoin, I did the back of the envelope, and it came to like $1 billion a year spend. And the Bitcoiners will protest that it's all being done with hydro, but then you've got to say, well, that electricity would be doing something else, and da-da-da. At the end of the day, your computational radiators are bad. So I don't think 5-10 years from now, there's going to be any real distinction in terms of energy footprint between blockchain and cloud. And Apple has pioneered this approach of trying to make chips as efficient as possible for thermal reasons and for battery reasons. That will feed back into servers. I expect the actual computational energy consumption to come down rather than up over time. The first question, here I have to put on my other hat. So I mentioned at the beginning this Hexiart project, a 30-year plan for rehousing hundreds of millions of climate refugees on the assumption that the world is going to do no preparation at all, and that what we need is a stack of really heavyweight, ready-to-scale systems, so that when it becomes apparent we have to rehouse 100 million people in a year and a half, we can do it. And I'm 20 years into that. I've been chipping away. The shelter was about the first 5 or 10 years. After that came a critical infrastructure modeling language, which will allow people to collaborate to design the critical infrastructure systems to provide water, heat, sanitation, healthcare. There's a modeling language, a bit like a pattern language for doing that, called simple critical infrastructure maps. Mattereum then slots into that vision as being the physical asset handling, both for tracking the money when you start talking about spending 20 billion a year doing emergency rehousing, but also for tracking the physical assets. So if you're in a refugee camp and you need a 10mm wrench to resecure a satellite dish, Mattereum 10 years out ought to be so cheap and so universal that if you deploy it in the camps, you can track every single physical asset so that you could take a very, very light load of things like tools and medical equipment and still provide services for everybody there. The thing that I want us to watch out for is this. It's very tempting for us to think that the environment is everybody's problem, right? But in actual fact, 50% of the human race have basically zero environmental footprint. About half of humans grow most of the food that they eat on land that they've been on for generations, using largely organic techniques. They have some interaction with things like forests or wildlife, but for the most part, their impact is practically zero. Then you have the kind of global working class who are burning, 8, 10, 12 tons of carbon a year. For France, the average is maybe 5, which means half of the people are probably below that. And then you have the top 10% of humanity who live in high-rise buildings, own SUVs, and have emissions on the order of 70 or 100 tons per person each. And that's really where the impact is. It's a few 100 million people with lifestyles which are incredibly lavish. And these things are sort of unconsciously aspirational. Before we got here, we went out and we bought a bunch of computer equipment so that we would have backup recording. And if I could actually see the number of gallons of water that were embodied in that iPhone, we'd need a tub half the size of this room to hold the water. And just that thing of we probably doubled our environmental footprint for a year of operations for the company just by buying a set of hardware to come and film an event. That's really where the damage is getting done, right? And with a little bit of luck, those phones will still be in service in 10 years, and that's how we will have spread the environmental cost. But we don't have to change the lifestyle of every human being on Earth to reach sustainability. We have to change the lifestyles of on the order of 1 billion people pretty radically, and then we have to start worrying about poverty, right? Because for one, half of the world's population, the problem is not they're doing environmental harm, the problem is they don't have enough to eat. So, development on one axis and getting rid of the overconsumption damage on the other axis. And my hope is that if we get the circular economy thing going, I've been toying with this concept we call spiral economy, which everybody hates, but just as a nutshell version, we continue to run the cornucopia machine as hot as we run it now. Those goods fall into the first world, and then we kind of have the spiral turn so that as the circular economy turns, the goods are gradually moved further and further and further away from primary consumption, first into the second cities, then into developing world countries, then into developing world villages, then into schools in developing world villages. So the sort of notion that your old iPhone still has a service life of 15 years and it shows up as a classroom monitor thing in some village school in Bangladesh in 2034, that to me looks like how we're going to solve a lot of the poverty problems, because if we enforce longevity on the goods, as they lose value because innovation makes better things and we value the old things less, they get pushed out to the people that have no other access to those kind of goods. And it's only when something is obsolete, where there is something so good and so new that there's no point buying any old version, that the thing finally winds up being ripped down to raw materials, put into recycling. That as a model also fits very nicely with the stuff that you're talking about in terms of a stainless steel-based economy. Stainless steel, glass, these kind of things. If you manufacture more and more of your stuff in these essentially permanent materials, you get into a paradigm that we call permafacture. You make it once, you expect it to last 2 centuries, you make it in a standard size, like this is a cup, you drink out of it, it never needs to be touched again. And at a certain point, you've manufactured all of the stainless steel cups that the world needs, and then you don't really need to make any more. And we could do enormous amounts of work with permafacture. I don't know if you've ever taken a look around thrift stores, old polyester clothing. You can't tell it's old, it looks new. The only thing that changes is fashion. So you could think in cold climates, you could have a pool of polyester clothing that would still be working in 30, 50 years. And that doesn't mean you're not going to be making couture fashion in Paris anymore. It just means that the couture fashion in Paris is going to wind up being used for formal balls at Iowa high schools 15 years after it was hot in Paris. We don't need to be throwing stuff away. We need to be expecting it to be in use forever and redesigning accordingly. And we can design the financial incentives to get us there.
I think, can I just add something real quick to that? I want to say that, back to that digital value layer, I think really it all comes down to identity. And we need really identity for everything to be able to be circular. I don't totally agree with you, Vinay, on that, because I think that composability of materials is also good, because we're moving forward technologically. So a router from 1999 is literally useless to me and most other people.
Yeah, this is the hard obsolescence. That stuff is just done.
And I think that's actually a big part of the problem. And so we also have to be, but here's where I get excited about what they're doing. if you have that identity layer, it then becomes possible to like rethink what everything is to a more granular composability level focus. So eventually, the way that things get made will change, and that will then drive everything. So I don't even, these shoes, I don't really love the look of the shoe, but they're Vivo Barefoots, and they're ecological, sustainable, recycled shoes. And I'm wearing them because of what they stand for as opposed to what they look like. And they're cool. I mean, they're comfortable. It's good for walking around. I like them. But the point here is that this is a shoe that is like thinking forward. It's like additive manufacturing. It's fully like vegan and recycled. And it's pretty cool. And the way that they're manufacturing is changing because they're thinking about circular economy. This is a B Corp, and it's a circular economy shoe. And so I'm wearing the shoe because it's those things. And I think that what's going to happen is composability is going to become much more important. And you really see it with Re. Like, this is all about composability. You have different brands on the label, but the bottle stays the same. Well, what if it happens with like cars, right? Like, how do you get to composability within cars where things can go back and, as Bill says, go to reuse, but they can go back through the supply chain. They can go back to being a commodity, cradle to cradle, and then come back as another life form, right? So it doesn't have to be the same life form. I don't necessarily want to wear your polyester from 1987, but I might want to like have your polyester as part of my shoe. And so I think that's a really important part, and that comes down to chemistry and chemicals, and the essence of cradle to cradle, which is rethinking from the beginning of the production of the product through. And then to your question about these communities, with VO2, there will probably eventually be an app, but the reality is 90% of even indigenous communities deep in the Amazon are on smartphones. I spent a month in the Amazon last year, and I was shocked how much time people spent on Instagram, even in the tribe. But the point is it's not about the web. It is about the web because the technology has to be on the open web, but it also has to be on the phone. And you can do everything from a VO2 standpoint with a Chrome browser. So I think that's super important. Is it the easiest? No, but it's absolutely possible. And the second thing is, I mentioned the validators. We're talking to like TNC, we're talking to like Punch Mama Alliance, we're talking to the Rainforest Network. We're having a breakfast with all of them on the 10th to talk about it because they're the interlocutor between indigenous communities and us. And so we're building a payment platform for the validators to be able to earn for validating indigenous lands that are being staked, or even just to help them do it. So it doesn't really matter, as all you need is an identity, and then we can pay you to your identity, and that's super simple. And so I think that's going to be a really important part, and indigenous and original nations communities around the world are the #1 community we want to pay VO2 to, because they're the ones that are protecting 80% of the world's natural areas. Matt, do you want to add anything on this?
Well, so much has been said already, but I'm really encouraged by what I think is possible now. And I think the influx of money into the space is what's really encouraging. So it was great to hear from a financial side what is occurring, because just looking back 10, 20 years ago, that was not always available. And I encourage those kind of entrepreneurs, those startups, and even the big companies who are looking for funds. To me, it's very apparent that there is more available in the last year than there has been in the history of this space, which is great. But also, too, I would also implore all of you that if it doesn't work for the consumer, the business opportunity, that CFO is not going to be so happy with the investment they made if it doesn't work.
I don't know where we're at on time, but I think we probably need to.
I think that's a great point to end on.
You wanted the last word, Greg? Why don't we give the last word to Ourania?
Yes, thank you. I just think everything that has been discussed is really encouraging, and just starting on what Matt said about making sure that everything works for the consumer. And I think ultimately we're all talking about the very same thing, traceability and openness, and how we can put trust into reuse and secondary raw materials, essentially. So it's really exciting to see that there is a lot of technological innovation happening on that. And yeah, really looking forward to the day where reuse and secondary raw materials have the value and people have access to that value and access to that information to use them, essentially. So thank you.
Thank you, everybody. This was fantastic.